Welcome to There's Nothing Artificial. I'm your host, Rich Heimann. Thank you for joining me on this journey where we explore cybersecurity, artificial intelligence, and machine learning, as well as their intersection without any hype. In this episode, we will discuss why machine learning for threat detection is so hard despite offering a paradigm shift by providing tools to learn directly from adversaries. So first, a small primer on machine learning. Machine learning broadly fits into two categories. The first is called discriminative modeling, or supervised machine learning, which models decision boundaries between classes, like spam and not spam, or dog and cat. Modeling explicit boundaries between classes is almost always superior in performance, especially when there is a lot of training data. Support vector machines, decision trees, and some artificial neural networks fit into this family of machine learning, as they learn explicit boundaries between classes. Almost all of the progress in machine learning or artificial intelligence over the past decade has resulted from supervised machine learning, which is very good at classifying noisy inputs based on known situations. These situations do not need to be described precisely, as they would with traditional software development. Instead, so-called labeled data can represent those situations. However, supervised machine learning is not perfect. First, training data needs to be labeled based on known situations. For some tasks, acquiring labeled data is painless. For example, obtaining labeled data to classify dogs is easy. There are only a few hundred recognized dog breeds, and dogs are easy for anyone to identify, and data is free on the internet. It's much harder, however, to acquire every cyber threat. There are too many and requires skilled personnel to identify them accurately. Plus, you cannot forget that acquiring labeled data on 0 days in advanced persistent threats because we lack knowledge altogether. Moreover, supervised machine learning struggles at classifying data outside of the known problem space represented by data because it learns to fit data as closely as possible locally, regardless of how it performs outside of these situations. This means supervised machine learning is good at interpolation, but needs improvement at extrapolation. So, despite all the buzz about AI, these solutions do not solve problems like humans. Each requires design for a specific problem, producing a narrow statistical approximation that interpolates signals, not the type of learning humans perform. To make matters worse, we lack completely homogenized data sets in cybersecurity. So, since threats cannot be identified in advance, and adversarial tradecraft is distributed across various data sets like firewall, Active Directory, DNS logs, etc., supervised machine learning will be challenging for some use cases. It will consequently need help as a unitary response to threat detection. The second category of machine learning is something called generative modeling, which models data distributions. Generative models are sometimes called unsupervised machine learning, although this is a generous label. They have much higher error rates that are achieved much faster than supervised machine learning. They also require more domain knowledge, since you are not simply training an algorithm with labeled data. However, they have some desirable features, some desirable characteristics that are especially relevant for threat detection. First, they are suitable for anomaly detection and are more robust to underlying changes in data distributions, like changing network behavior over time. So, while in theory discriminative modeling or supervised machine learning is better, in practice threat detection requires both paradigms. And one of the reasons why Silver Sky uses a mix of machine learning models from different learning paradigms. This is problem solving 101. The less specific one problem is from another, the less effective any solution will be, including machine learning. In threat detection, the best we could hope for is to find an optimal partial solution for each data set and each threat vector and combine them into one solution. For example, Tesla uses dozens of machine learning algorithms and components to recognize narrow, well-defined objects. There's a partial solution for stop sign recognition, and others for lane markers, and more for identifying vehicles. At Silver Sky, we have taken a similar approach. Silver Sky's MDR uses a meta-algorithm for distributed learning over the whole of the cybersecurity problem. This approach includes dozens of combined learning algorithms working on various parts of the threat detection problem. Such a strategy is essential for iterative and adaptive computation, showing threat detection as both dispersed and connected. I will come back to this point in a future episode. One of the least stated facts about machine learning is that it's not perfect because it can't be perfect. Machine learning produces probabilistic outcomes. Probabilistic outcomes are more robust than inflexible traditional security, like rules and knowledge bases and signatures. However, probabilistic outcomes don't know anything and still produce false positives, false negatives, and inconsistent user value propositions. Moreover, and as the name suggests, trace evidence provides a poor signal-to-noise ratio. Consequently, designing algorithms to detect trace evidence with a poor signal-to-noise ratio produces weak signals, which means a solution that performs, if you're lucky, slightly better than guessing. Ultimately, machine learning is limited by its weaknesses and the amount of information in data, making machine learning strengths paradoxical. Consequently, many real-world applications, including Silver Sky's MDR platform, still use expert systems and knowledge bases in the background of their machine learning solutions for stability, and ultimately a more complete threat detection response. So, in conclusion, there are a lot of interpretations of this information. The worst is that because machine learning is imperfect, it is unimportant, and this is categorically false and lacks any nuance. We can't throw the baby out with the bathwater. Nothing is perfect, and talking about the limitations of a solution is not to reject that solution. We need to understand that it's not 2014, and we're past peak AI hype. A vendor saying that they're using machine learning or artificial intelligence doesn't mean a lot, nor does it automatically indicate that they have a superior solution. In fact, it could be worse if they don't understand the inherent limitations, or they misunderstand the complexity of the threat detection problem. The best advice that I have for technical leaders is to develop better intuition about these technologies and ultimately strip them away from any hype or the anthropomorphic marketing claims. That's all I have for you today. Thanks for joining There's Nothing Artificial. Stay secure.